Hello, everybody. My name is Shannon Lal. I'm the CTO of Designstripe. Today, I'm going to be giving a talk about kind of some of the work that we've been doing with integrating AI models and in a 3D renderer on Google's JKE, Google's Kubernetes engine. All right, so I'm going to give a quick intro about myself, a little bit about the company. I'll do a quick little demo just to kind of give everybody a bit of an understanding of what we actually do. And then I'm really going to talk about kind of what were the things that we ended up doing to get our performance and costs down. And then I'm going to talk a bit about kind of where we're still going, because there's still more work that we need to do. Alrighty. Okay, let's talk about the elephant in the room. For those of you who have seen, I've got this beautiful black eye going on right now. It happened about a week ago. It was fairly painful. I'm going to try to milk it as much as I can to include a little bit of humor as much as I can, because it was a very painful experience, but we'll go from there. Alrighty, so as I said, I'm the CTO of Designstripe. Before that, I used to work for RBC for a couple of years. I helped build their digital office here in Montreal, and then before that, I spent about 5 years with a company I was through an acquisition called InView. The current tech stack that we're using at Designstripe is predominantly Next.js and SJS, so TypeScript. We do have some parts that are Python, and we do a lot of LangChain and Mongo for a lot of our AI type work. And I'm married, father, and an unpaid Uber driver. For those of you who are parents, you probably understand what that means. Okay, so I'm going to go flip over to a demo mode here. But just in general, Designstripe is a smart design platform. Our real target audience is to help small businesses build marketing assets, right? So we're doing things like social media posts and 3D rendering. So I'm just going to shift over here, and I'm just going to do a quick little demo. Oh, I'm going to bring this over. Sorry. Just to bring this over. I probably should have mirrored over, but I'm mirroring right now. And yeah, okay. So this is basically our platform right now. Let me actually close the developer console. That'd be awesome. Sorry, I should have. Okay. So from a user's point of view, they can come in, and what we do is we go and we look at their website, and we scrape their website. So here we built a summary of the company's website. This is right now Designstripe. And we build this out to kind of get a description of the company, what they're doing. We pick their colors, which is one of the key things from a design point of view. We identify the industry that they're in, as well as the tone. Is it a humorous site? Is it a good site? Professional, and then we pick up fonts. And then with this, we're able to we're now able to build social media posts. So if I come over here and create a post, I'm just going to take my glasses off. So what we've done is we've built out topic suggestions on what they can post about based on their brand. So we looked at the information we scraped from the website, and we're trying to find relevant topics that they can post about for today. So over here, we're going to build this out. Obviously, I'm doing a live demo, so it's probably going to fail. Nope. So here I've got some topics and some posts that we can go, and we can basically pick one of these, modify them, and go directly to our to your post onto your social media platform. So I'll grab this one. So again, all the text is pulled out. We have full design capabilities from this. The reason I'm demoing this off is that an earlier version of this, the image generation we were doing using Stable Diffusion. And that was some of the initial work that we had done for hosting our own AI models with Stable Diffusion, and we were running that on Google Cloud's JKE. So this is one of the, so obviously we're using a lot of LLM calls, so Gemini, OpenAI, Anthropic is to generate all the text. And then the images, we've kind of built our own stock photography, but we're using Midjourney. And now we've just recently integrated Ideogram, but in the past we were using Stable Diffusion to generate these images. Okay, so then the next thing that we have here is, and this is where I'll be focusing a lot for the talk on, is we've built a custom 3D rendering engine. And what this allows a user to do is to come in, and basically what we're doing is you can build an animation. Of course, this probably won't work. Let's see if this goes. I think the network connection is a little bit slow. There we go. So I just grab this, and I can apply. And so now I can come over here. So now what I'm doing is I'm building a preview of what this is going to look like. And so now I can build out a video. And so this process will take about 10 to 25 seconds to build this out. So in the background, what's happening is there's a 3D engine that's using a GPU to basically build out the video for this. And so you can take this and post onto either TikTok or YouTube and quick product placement videos. And we can do this in about ideally 20 seconds. We'll see what's going on. course, I'm doing a live demo, and it most likely won't work. Ah, it's working. Okay, give it, I'll do a little dance while this happens. All right, hopefully it can do this in the next 7 seconds. Right now, it's always doing live demos is always a bit of a risk, but why not? Let's hope it doesn't crash. There we go. 90 cent, 94. All done. Oh, I think my network connection's a little bit slow. There we go. Yeah, I think the network's a little bit slow. So in there right now, there is a 3D rendering. I'll probably show that afterwards, just because I want to keep an eye on the clock. But we've got a short 3D video that's about 10 seconds right now. We can do that in about 30 seconds. All right, so just give me a second. I'm going to go back to this. All right, slideshow. Okay, so that's a little bit about Designstripe. Any questions before I proceed? Okay, so before I start to get into some of the talk about AI models and all the optimizations we want to do, I want to just kind of make sure that we're all on the same level playing field here when we talk about AI models and GPUs. So when we specifically are talking about AI models, I'm talking about LLMs. I'm talking about things like stable diffusion, so text-to-image generation. And from the LLMs, we're really talking about some of the open source models that we talked about, so Llama 3, Falcon 7B. These are the big models that require a heavy GPU. And when we talk about GPUs, what we're talking about here, one of the main differences between a CPU and a GPU is that I've got some funny little images. I was trying to add a little bit of humor in here, but on your CPU, they're really highly optimized for doing sequential operations. And there is a lot of applications where this is really, really important. For GPUs, they're really, really highly designed for do things in parallel. So 3D rendering, graphics cards, that's why they're called a graphics processing unit, is that they're really optimized for handling large applications, especially matrix multiplications, if you guys remember your linear algebra, to do that all that work in parallel. And that's really one of the key components from a GPU point of view. Okay, so I'm just going to start to talk about the architecture, and then we're going to start to get into kind of the steps that we did. So from an architecture point of view, we have our front end is React or Next.js hosted on Grisel. We have kind of a middleware, which is most of our Node.js that is all running on JKE. So that's all TypeScript running. We have kind of our PubSub, Google PubSub is kind of a middleware where we do a lot of our async workloads. And then we have our GPU nodes that have GPUs attached to them, where so all of our AI workloads, or specifically right now, our 3D rendering engine goes from there. Any questions so far? All right, I'm going to try to add a little bit of humor and milk this black eye. So I've got two options here. I just want to show of hands and how I got this beautiful black eye. So option number one, I woke up late one night at 3 o'clock in the morning and hit my door going to the bathroom, or I was trying to do the Macarena and elbow myself in the face. So just a show of hands for option number one or option number two. Two? I'm really not that good at answer, Thanks, guys. All right. Okay, so now we're going to get into the meat of some of the work that we did. And I really just, I'm not going to read out all the steps that we do. I'm going to go through them in a little bit of detail. Two things right now. The main issue that we're trying to solve here has to do with basically cost and scale, right? So for those of you who've been working in the AI space, you know that GPUs are exceptionally expensive. An A100 is around $3,000 just for one. That's just a GPU is around $3,000 a month, right? So for a small stage startup, it's really, really expensive. An H100, I don't even know what the price is on those. I think that's like $16,000 to $20,000 a month. It's pretty crazy pricing. In our workloads, we're using T4s, which are like the older generation inference models. So they're like, I think even then they're $350 to $400 a month. So they're still really expensive. So we're trying to figure out a way to have a kind of a real-time experience for rendering videos, but also keeping our costs down. And then the other thing that we're trying to deal with is scale, right? Our traffic is very peaky. We have people coming in at lunchtime, coming in at 9 o'clock, and then we have nobody on our site. Well, not saying nobody on our site, but very low traffic on our site. And then we get these peaks that happen right now. So we're trying to figure out how do we handle these burst traffics of a lot of people coming in and then going up and down. So those are the two things that we're going through. So as I go through this right now, if you guys have any questions, anything, by all means, please raise your hand, ask why. I'll try to go through this. I want to make sure that everybody gets kind of the gist of where I'm going for. Okay, So the first thing that we did had to do with basically enabling horizontal pod auto-scaling. So this is a feature built into Kubernetes that allows you to horizontally scale the number of pods. So if you run your CPU workloads on Kubernetes before, this is a pretty simple thing to do. The trick that gets it a little bit more complicated has to do with we needed our workloads to run on a node that has a GPU based into it. And that's one of the tricky things we had to solve with. And so as we spin these things up, we needed a mechanism to scale. So how we did this is that we use PubSub as kind of an intermediary, right? So when a user requested a video to get rendered, we would put these messages on the topic, and then PubSub, our rendering engine, would pull those messages off and render them. So as more users came to the system, we put more messages on the topic. Google PubSub and JKE would start to recognize that the queue was basically getting backed up. It would then use the HBA to start auto-scaling and spinning up more nodes, and that's how we handle our traffic. So I put some notes there on like the main message that we were doing for subscription was the number of undelivered messages that we had. So perfect, problem solved, right? No. I was talking to Alan before from Google. One of the challenges right now is that this takes minutes. So if you're thinking, hey, cool, I can just go drop my Llama 3 on a GPU and only pay based on usage, you're looking minutes to get this up and running. So if you have workloads that run in the background, perfect. But if you're trying to build an application that serves clients' needs right now, and they've got to wait minutes, you've got to find some optimizations on that. Okay. So the next thing we did had to do with optimization of our Docker containers, right? So basically, what we did is that we have our application, it's basically bundled into a Docker container. And so some of the key things that we started to notice is that it was taking a minute or so to pull these Docker containers down into our nodes. Now, our Docker containers are fairly large, and if you're using things with like Stable Diffusion or any of the bit large LLMs, those Docker containers are going to be big as well, right? The weights for those models are fairly large. So ours was about 20 gigabytes. So we really need to do some work to kind of reduce the size of that. There's only so much you can do because the NVIDIA base image is about 5 gigabytes still, so there's only some control that you can do. But we did a lot of work to kind of reduce the size. We introduced a multi-build step, which built our artifact and then only brought over the artifact onto our image, so that really dropped their cost down, or sorry, not cost, the size down. So we got it down to about 10 gigabytes. The next thing we did was we moved from, we were previously on Google's container registry. So for those of you who don't know, that is basically the equivalent of Docker Hub. We moved from container registry onto artifact registry. And then we worked with Google they kind of recommended to say, instead of doing a multi-region repository where you store your Dockers, they went to a single region. And by doing that, we got a speed up of about, we went from about 60 seconds to do a pull to about 2 to 3 seconds. And the big factor in that is that we were doing a lot of our deployments from GitHub Actions. So we build the image, we push it up, and then our cluster would try to pull the image down. But because it was multi-region, it was trying to replicate that across basically the entire US. So we went to a single region, US East 1, which is where like 90% of the traffic was. But we got to save speed up of about 2 to 3 seconds. Go ahead.
Yeah, excuse me. 2 to 3 seconds for 20 gigabyte artifact?
As we got it down to about 10 gigabytes, but we got it down to about 2 to 3 gigabytes, yeah. Yeah, but remember now, our cluster is in there, right? So even then, I thought it'd be even faster. But that was the thing that we noticed. From like, why is it taking, it's still 20 gigabytes on a network within Google's infrastructure. That should be like seconds. Yep.
Sorry, back on your previous slide where you talked about the PubSub metric that you were using.
Yep. Yep.
And you said it takes like a few minutes to scale up.
Yep.
I wondered, because I've seen this similar kind of problem on PubSub before, had you tried using a push subscription on PubSub, then you would have seen a lot of HTTP traffic. Is there a reason you didn't go through this route?
No, so honestly, like when we were looking at it, it's like we Googled and said, what's the recommended? So 2 things is that, one, the rendering time can get up to 30 seconds, right? So going with HTTP traffic, we'd start to get into timeouts, right? So if we had 2 to 3 in there, we were talking timeouts. That was going to be basically the whole main reason to go into this to a different mechanism right now. Yeah. Yep.
So the 20 gigabytes is on the GitHub action push. How is that pull?
So basically the issue is that, I mean, it's our artifact was 20 gigabytes before, right? So when you're having to pull that image down, right, we were looking for optimizations. You got to pull down a 10 gigabyte file versus a 20 gigabyte file to launch your container. It's 10 gigabytes is going to be faster than a 20 gigabyte file.
Using unicast pooling, so it would use your closest region to pull anyway. So I don't understand why.
So what was happening is that when our GitHub our repository is multi-region. So GitHub would push, and then right after we pushed, we would automatically tell Kubernetes to start pulling. So we were pushing to a multi-region, and then like within milliseconds, we were telling Kubernetes to pull that image down immediately. So because it was multi-region, GitHubs might have been pushing it into a different US region, but we were trying to pull down, and our cluster was in US East 1. So that synchronization between them.
That makes sense, but it's not immediate.
What's that?
It wouldn't be immediate. I mean, when you're pushing your images, it'd be once per hour. How is an image pull on scale up that can happen after 30 minutes and already have the image in multi-region?
So in our environment, we were deploying immediately, right? So this is not building and then later deploying, right? When we go to production, we use GitHub Actions to go to production. So we have a branch for our main, and then we have a branch for release. So it's GitHub Actions that triggers a release. So it's kind of, we're trying to get to a continuous delivery model. So we're pushing directly. So that's our workflow. All right, pull number 2. All right, so raise your hands here. Option number 1, my son got upset with me, and when I said no more at gaming, and he threw his Xbox controller at me. Or option number 2, I was trying to impress my wife and was doing cartwheels. Show of hands for option number 1 or number 2. All right, number 2. All right, I will do the big reveal. I am trying to make this a little bit of suspense here. Okay, so one of the other reasons I talked about when we went from Google's container registry to artifact registry, one of the other big features that happens there is there's a new feature in artifact registry called image streaming. And basically on container registry, the way it would work is that you have to pull the entire image onto the Kubernetes node, then it would attempt to start it. With image streaming, what it does is it allows you to basically pull, and it's kind of basically but behind the scenes just kind of faking a virtual drive. So it's kind of like letting Kubernetes know, hey, your image is already ready to go. You can start this process. And so it's kind of doing like an optimistic start. And what it's trying to do is in parallel pull the rest of the image down. So it allows you to start your image a lot faster. You don't have to wait for with container registry, you would have to wait for the image to be there. With image streaming on artifact registry, you can have the image on the slide and just start to go right out of the gate. Okay. All right, this was not really much of a performance optimization. It's just more like a painful lesson that I kind of wanted to include in there. For the DevOps people in there, you're going to be like, what the hell are you thinking? But for those of us who are new, it was kind of a very painful lesson that we had to learn. So before, as an early stage startup, we were really trying to keep our costs down. So we had, like I think it was stable diffusion, and we were doing some rendering work. So we had like a node with 2 GPUs on it, just trying to keep our costs down. And what's happening is that we were pushing our 3D rendering often to test out development. We had them on the same workload, but these are still big images. And what happened is we started to get into a situation of disk pressure, where the disk was basically filling up on our node. And basically what was happening is that our production stable diffusion would start to flutter and get under pressure and fail because of our 3D rendering and on the same node. So just, if you're going into this space, just a painful lesson to learn is I would really think about having separate nodes or node pools for your different workloads. So if you're going to have like a Llama 3, maybe think about having a node pool specifically for that. If you're looking at having a stable diffusion instance, think about having a different node pool for that, because they will, depending on how often you're updating, those images are big, right? They're not like your Python servers or your TypeScript servers. They're going to be in the gigabytes, and they're going to be pretty huge, especially if you got large weights. So just think a bit about how you're optimizing that as well. Okay, so this is really where we got into a lot of the cost optimizations right now. We were stuck in the situation where I think at one point we had about, and this is sort of not huge volumes of traffic, but we had about 6 GPUs and 6 nodes running all this workload. And our bills were well within the $5,000 to $6,000. And for a small startup, that's still a good chunk of money. That was just That was just on the JKE side. We still have OpenAI bills and Anthropic bills and other LLM bills. So we really needed to find a way to get our costs down. And so initially, in the demo that I had, we had a process for generating the image that you saw, and then we had another process for generating the video. And so we had separated them out because the GPU requirements were fairly large. So we did some optimization on this to basically allow both of those processes to have on one single GPU. And by doing that, that's when we basically cut our cost in half. And so we had to optimize our workloads so that we could basically fit both of them onto a single GPU. And that basically cut our costs in half. And so what I want to bring this up is that I've done some work in the past with LLMs. And so I think it was about 8 months ago, I put a little blog out there where you can run, I was running, I think, a Falcon 7B on an L40, a GPU, which is an NVIDIA L40, which is like their newer inference model, GPU, I should say. And I had that running on a single GPU node. So if you are looking to deploy your own models, again, this is not going to be for the large Llama 400 models, but for, let's say, you're running like a workload, it's like a Llama 3 on a 7B, you can try running that on a single GPU and maybe having 2 instances. I think on the performance I tested, it was like 12 seconds for one inference call, and when I had both of them running in parallel, it took about 16 seconds. So there is a bit of more latency, but if you are looking for some optimizations to keep your costs down and be able to serve traffic, you can look at running, on a single GPU, you can look at running multiple LLM instances if the memory requirements are there. And then the next thing you can look at doing is, we haven't done this yet, but on the large GPUs, so like the A100s, the 40 and the 80 gigabytes, and the H100s, you can do what's called splitting of the GPU. So at the JKE level, you can basically trick it and split your GPU to have it almost, I think it's like 4, maybe even more. So on a single node, if you have one A100 GPU, you can actually split that so that Kubernetes sees there's actually like 4 GPUs on there. Now, again, the A100s started around $3,000. So, depending on your workloads, it maybe makes sense, right? So that's another optimization technique you can do. Okay, so let's talk a little bit about some of the optimization stuff that we've done. Let's keep an eye on the clock. Okay. I do want to preface that we did not do this as a research exercise. We were basically in a situation where we launched this cool feature, and then our costs were really, really high. We had to pivot quickly and be like, how do we get this down? So a lot of the steps we did was not in preparation for a presentation. It was really like, we just needed to get this work. And so I can talk about it, but I don't have all of the exact calculations of every single step that we did. What was the performance gain on that? But I'm talking sort of at a high level. So the first thing that we did is, obviously the baseline that we wanted to go with was using that horizontal pod auto scaling, right? So we had that configured with PubSub, and we needed to figure, once that was up and running with just that, no image optimization, when we started putting a bunch of traffic onto that PubSub queue, how long did it take for more nodes to be spin up so that we could have more of our rendering pods in parallel? And what we saw was about 6 minutes. And I've been talking to a couple of people. You're looking in and around the 3 minutes or so time frame for doing this. So unfortunately, it's not at the ideal situation for serverless, especially for early stage startups, where ideally you'd have this sitting there and pay no cost, and then as the user comes in, within a couple of seconds, you'd have your LLM or your rendering engine up and running quickly. So just keep that in mind. It's really designed for large scale workloads as you're getting traffic and you have these bursts to start scaling this stuff, but it's still within the minutes of time frame. So the next thing we did is we factored in all of the image optimization stuff that we did. So moving to a single region, the reducing of the Docker size, including image streaming, and what we got it down to was about 4 minutes. So again, now with the optimizations, spinning it up, we can get a node up and running on the HBA with our rendering engine up and running in about 4 minutes. So then the next test I wanted to see, and this is where I was trying to figure out in terms of moving forward, where is the optimization that we need to do? So I went into my cluster and I basically pre-warmed a couple of extra nodes. So I think we had 3 nodes in our node pool, or 4, and then I just said, you know what, I'm going to add in 2 more nodes. So I had 6 in there. 2 of them had no workloads on them. So they were there, they were warm, they were in the node pool, and nothing on there. And then I pushed traffic onto our topic and waited for basically PubSub and the JKE to then say, oh, I now need to spin it up. And that still took about 2 to 3 minutes. So even with the nodes already sitting there empty, it still takes about 2 to 3 minutes for PubSub to say, hey, I got to get it, and then go in and spin this up. And then the last test I did was I basically reproduced where I had a bunch of pre-node empty nodes there sitting there, and I manually went in and I manually auto-scale. I said, okay, change the replica set from 3 to 4. And doing that took about 10 seconds. So a lot of the image optimizations that we did, we could really get these nodes up and running fast. It just seems that the next step that we need to really focus on is going to be on how do we get the HBA side of it, how do we notify Kubernetes to spin up more nodes is really where the work needs to be done. Any questions so far? Yep.
So the problem is more in the detection
Yeah.
of the PubSub rather
Yeah.
than anything else, because your last result of the scaling in
Yeah.
10 seconds proves that.
Yeah.
You're addressing the HPA problem or the PubSub problem, not the actual deployment. So
Well, I mean, there was still work that we did, right? I mean, if we hadn't done the image optimizations and moved to a single region, and
it would have taken 30 seconds instead
right,
of
yeah,
10.
still, yeah. So there's still that's right. Now, the thing is that I don't think, when Google is probably in these, and it's not just Google, right? Amazon and these guys thinking about it. They're thinking about like you have large workloads, right? 20, 30, 50 servers running, and you've got massive traffic in there. We're thinking of a use case, to be brutally honest, where it's like, I have 0 traffic, I want to pay 0. I get 4 people coming in, I want to get 4. That's not their use case that they're trying to do with, right? That's a small stair setup. If I have nobody on my system, I don't want to pay anything. And when I get 4 people in, I want to have that thing up and running instantaneously. And I only want to pay for that. So I don't want, it's a much more complicated use case to solve right now. But yeah, that is what needs to be done. Any other questions? Yep.
Hello.
Hey.
Great. Just for the preloaded nodes, is it a price that you have to pay?
Yes, yeah,
for that?
absolutely, right? So I was using, let's say, I think it was like 3 nodes that were in use. And then I went in there and I just said, add another node that was empty to the node pool. So I was obviously paying for it. Yeah.
Can you set up these on schedule, like to prepare for those peak times?
That's where we could. We're still like if we were a larger organization that had traffic patterns that we said we know on average we're getting like 1,000 people or 10,000 people coming in at 9 a.m. for that peak traffic, then obviously we could start to spin up and scale. And I would imagine that a lot of larger, medium-sized companies and have better traffic patterns, they can start to do that as well. Yep.
Did you try out, because essentially you're trying to replicate serverless on Kubernetes?
Yeah.
Yeah.
That's one of the things that we're looking to. Okay. All right, next steps. I was just talking to Alan from Google before this. So we started this process probably about, I guess, maybe 8 months ago. And at the time, we had actually had all of our infrastructure on Cloud Run. And at that time, Cloud Run GPUs were not available for Cloud Run. So for people who aren't familiar with Cloud Run's kind of like a serverless platform. It's designed for primarily Docker containers. We can spin up a Docker container. And one of the things that's a little bit different from serverless functions is that it gives you a little bit more fine-grained control, where you can go in there and say, I actually want to have one instance always running, and now I want to just have auto-scale. Whereas with serverless, it's basically all or nothing. So we had all of our workloads running on Cloud Run, but then we needed to go to a different platform to have GPUs, and so we ended up migrating away from Cloud Run and built out our Kubernetes cluster, and we were working with the Google team in, I think it was August, and that's when they told us that, oh, by the way, Cloud Run is having GPUs coming in beta. So I'm on the wait list right now trying to get that, and I'll probably share that in the next week or two about some of this, but it is one of the things we're going to try to see what the performance is of having Cloud Run running on a GPU. I think the big concern that we're going to have to see is cold starts. That is the big concern always with serverless, is like, how long does it take to spin our workloads up and running on a GPU? So that's one of the next things. Another kind of optimization we're going to look at, and this is more for if you're doing a lot of LLM work, you can configure your node pool, and what we're doing right now is baking in the NVIDIA base image into our node pool. So the NVIDIA base image, so if you're using any kind of like LLM workloads with NVIDIA drivers, that's about 5 gigabytes that's in there right now. So you can build a node pool that has that base image baked into it, right? So when your Docker pull has down, if you're doing Llama 3, you don't have to pull down from the cloud the NVIDIA-based drivers. It's already going to be on the nodes. When that new node comes up, the NVIDIA drivers are already there, and you just have to pull down the rest of your stuff. So it's, again, it's a minor fine optimization we're looking to do, but it is something you can look at doing. And then the next thing we're going to look at is we might actually revert back to having nodes with multiple GPUs on them, and maybe have sort of like 2 workloads running with 1 extra empty one. So when we get these bursts of traffic, so we have one already ready to go, and then we can scale from there. Again, we're going to play a little bit around with that. Any other questions? So, okay. All right, let's do the big reveal. I've been sort of teasing a little bit about this eye. So let's see how this goes. So this is what I looked like 2 weeks ago. Oh, you know, a little bit of Photoshop and stuff, but yes. All right, this is what I looked like on Wednesday. Super awesome. This is what I looked like on Sunday evening. You can see the nice scar there. And this is what happened pretty much right afterwards. So last Sunday, I was in Gatineau with my son. I'm also, as I mentioned, an unpaid Uber driver. I'm also an unpaid hockey coach. And I was on the bench in the tournament, and I was yelling at some kids to get in position, and another kid was coming down the side, and he tried to clear the puck, and I got it right here, and fell to the ground, got back up, and said, I'm okay. And my head coach is like, you're not okay. We need to get you off the ice, because I had to just like collapse like this and right down. Yeah, so beautiful black eye, nothing like having to give a presentation at a conference and coming in with this amazing black eye. All right, over time. Okay, so I just want to say a big thank you for everybody coming to my talk. I want to give a big shout out to Alan and Ugo from Google for all their help. They really were great in helping us get there. A big thanks to Jin, I'm not sure if he's still around, for just helping with the conference. If any of you guys want to connect with me on LinkedIn, by all means go in there. I've also got my link to calendar. I work at remote, so I work at home. So if you have any questions, you want to get any information about AI, you want to get on like a WebEx call or a Zoom call, and you just want to talk a bit about kind of how we can do AI integration, by all means hit me up. But again, a huge thank you to everybody. I appreciate for coming out, and hope you learned a bit here. I will be around for the next little bit, so if you have any questions, you want to pick my brain, yeah, coming over. Again, thanks everybody, appreciate it, thanks.